Okay, in this code walkthrough, we will see how the disconnect event is handled. So now we have the connection to the server, and soon I will press the disconnect button and we will see what happens then. But before we go there, we'll take a look at the current status of the protocol implementation. The connection reader thread is running now, but it's not doing anything. It's currently, the reader is blocked here in the read loop. Nothing is coming from the server, so the thread is here stuck, so to say, waiting for events to happen. We can take a look at that in the debug window. We can see the threads, and we can see that the running reader thread is running there, doing nothing, and so is the writer thread. Okay, reader is waiting for data to come in, and writer here in the run is blocked, waiting for the protocol to open this condition variable when there is something to send. And the main thread is running, ready to handle any events from the user, like pressing the disconnect button, which I will do now. Okay, so here again, when we go in the control interface disconnect method, we see that the model is handling that event by forwarding the call to protocol implementation disconnect method. Here we will first check that if there is a connection writer, we will then ask it to stop sending information. Okay, what is happening here is that we set this running variable to false, so we don't anymore want to keep running this thread function run here. When this is done, the function actually exits, and the thread is then finished. But the condition variable was here blocked, blocking the execution of this thread function, so we also have to open that condition. In that situation, the execution continues ahead from this blocking call. The thread will check if there's anything to send. There isn't, so it will not send anything. Then it goes back to the running loop, notices that running is now false, and the function quits. So that is the way we are able to finish this thread. And the protocol implementation waits for that thread to actually finish. We could check here, can we see it anymore? No, reader is still there, but the writer isn't. So you notice that sometimes it's useful to give threads names, like I do here. In the writer, I set the name of this connection of writer thread to be CWP writer, and the reader also has its own name. So I can then see from the threads list if my threads are actually there or not, and what is the state of those threads. Then, since it's already finished, if it would still be not finished, this join would block, but since it's very fast to exit that thread function, it has been already done. Okay, then it's the turn for the connection reader. And check also that we set the connection writer to null at this point. Then we stop the reader. How it is that done? Okay, again we set the running to false. Now we also want to close the connection to the server because we don't need it anymore. So we will close the output streams, input streams, and the socket itself. It would be perhaps just enough to close the socket. The stream would close also at that same time, but well, you can do it also like this way. Okay, so we close these and then the socket and null it and set the state of the connection to disconnected, and then we wait for this thread actually to finish. But then you notice that I have this breakpoint here set to catch the IO exception. Why did this happen? Well, it happened because we were having a blocking read call here, and when it fails for any reason, so it was closed in this case, it will throw a socket closed exception in that case. And what we do here is that we set running to false and change the protocol state to disconnected in this case. Okay, we switch to the context of the reader thread, so we can now continue the execution of that thread. Well, let's first put a breakpoint here in the disconnect, so we'll be able to see what happens there. I have also a breakpoint here in the connection reader run, where the state is changed to disconnected. But let's do it also here in disconnect and then resume. So now we did that. The connection reader is now finished. That thread function also returned, and that the thread doesn't exist anymore. So if you take a look at the thread list, you cannot see CWP reader thread anymore. Okay, so now we have closed these readers and writers and nulled the objects, and we don't have any connection anymore. So I will resume the execution of the program. Well, what now happens is that the reader thread changed the state of the connection to disconnected using this method change protocol state. So that's why protocol implementation run was called with the disconnected state, where we'll handle this state change. But if you notice, we are calling the disconnect method here again. Why? Well, I will return to that later. What happens there now is that we again start disconnecting, but since writer and reader are already null, nothing happens there actually. So nothing is actually done in this case, in this situation, because the connection was already closed. Okay, and now the application is in disconnected state. Okay, so why this disconnect call? We already did the disconnection from the user event. User clicked the button. Why we are doing it also here? Well, the connection can be disconnected for many reasons. One is that the user decided to do it. But what happens when, for example, the server crashes or the network goes down? And for that reason, the connection goes down. Let's see what happens in that case. I will again connect to the server. And now I will switch here where the server is running, and I will close it. Again, you notice that this IO exception happened. This is again because we were having a blocking read with the socket and its input stream reading and waiting for the server to send anything. And when this connection is broken for any reason, server crashes, network goes down or whatever, this causes the IO exception to be thrown. So we have to handle this case too. User doesn't close the connection, but the server or network being down causes this exception. So we have to also handle that situation. So now when I resume the execution of the application, we are coming here in the disconnected event handling because the reader caught this exception and decided that it's time to change the protocol state to disconnected. So that's why we are there. So now we have something to do here in the disconnect implementation. We will now actually, in a controlled way, we will stop the writer thread and reader thread and set the rest of the variables to the default state where they are when there is no connection. And that's it. Now that we don't have the threads, reader or writer threads here running anymore. And the connection state here in the user interface is also up to date with the real status of the connection, because the protocol notified the listener, which was the model, and the model notified all the observers, like the control fragment, which then updated the state of the user interface to reflect the context or status of the application and its connection. So that's why we have to implement this disconnect in this way. We can now, with the same code, handle both the user wish to disconnect by calling this actively from the user interface and then stopping the reader and writer. And on the other hand, if the reader gets an exception here in the read loop for some reason, we will then from the reader tell the protocol to change its state to disconnected, and the protocol in that situation will then call disconnect itself. Okay, so this is the way to handle disconnect event in the application.